Hey everybody, welcome to the Unit 2 review. This is over parent functions and a little bit of domain and range stuff. I summarized all the transformation stuff for you at the top, and we'll just refer to it as needed, okay? But I highly recommend studying this, okay? Make sure you know those properties for the test. So everything on the left-hand side is the we do section. That's what I'm going to cover in the video. I want you to do everything on the I do side on your own, on the right-hand side. So let's go ahead and get started. What are the domain and range of the cubic parent function in interval notation? Okay, so if you do not know what the cubic parent function is, it is f of x equals x cubed. And if you don't know the domain and range off the top of your head, if you know that it's x cubed, type it into your graphing calculator and look at that graph. So here I have x cubed graphed, and you see that it is unbounded, meaning it's moving left and right freely and up and down freely. So we're going to write the domain in interval notation. So domain would just be negative infinity to positive infinity. In parentheses. Parentheses indicate that you can't touch it and you'll never be able to touch infinity. And so it has an all real numbers domain and range. Number 2, what are the domain and range of the logarithmic parent function and inequality notation? Okay, so let's go over what you might see for the log parent function. You'll either see two things. You'll see it written as ln x, or you'll see it written as f of x equals log base 10 of x. Okay? Either way, it's still going to have the same domain and range. So I'm going to graph both and show you what I'm talking about. Okay, so I zoomed out a bit to show you both functions. They look a little bit different, but in terms of like the arc right in here. But like I said, they had the same domain and range. But you see I have log base 10 of x and then ln x graphed. You see that it is basically stopping on the y-axis. Well, not stopping, like it's continuing, but it will not go past the y-axis. It will never touch it. So it's like a waterfall effect. And so how does that affect the domain? Well, the domain can only be positive numbers then because it's only on the right-hand side, but it's never touching the y-axis, meaning it's never touching the number 0. So your domain is x is greater than 0. Not greater than or equal to because it's not touching it, just greater than 0. Now my range, it's moving down, you see that, freely, and then it's going up slowly but surely. So the range is all real numbers, and so in inequality notation, you just say it with that R with the extra line going through it. So what are the domain, range, intercepts, and line of symmetry for the square root function? So if you do not know what the square root function looks like, it's f of x equals the square root of x. Type that into your graphing calculator. So here the square root of x graph looks like this. What's the domain? Well, it's starting at 0 and moving to the right forever. So I'm going to say, and then it does not specify the type. So I'll write it both ways just because it's easy to write it both ways. If it starts at 0, then you go 0 and bracket, because it's touching it, to infinity. Or you say x is greater than or equal to 0. For the range, where did it start? 0. And then where's it going? Up. So the range is the same answer. 0 to positive infinity, or y is greater than or equal to 0. Now it says, what are the intercepts? The intercepts meaning where does it touch through in the x-axis? So you could say 0, 0. You could say the origin, whatever. I'll just say intercept is at 0, 0. And let's see here. The line of symmetry, I will abbreviate that as LOS. And there is none. You cannot split this graph in half symmetrically, whether it's this way, that way, or that way. Yeah. So that's number 3. Describe the transformation for the following equation. Negative square root of x minus 3 minus 6 from the parent function square root of x. So this is where we're going to refer to this chart up here. You have a negative on the outside. So my negative on the outside is going to make it reflect on the x-axis. So I will say reflect on the x-axis. Now that I've got that, what is that minus 3 doing? It's part of the square root, so that means it's inside. So you are minusing something on the inside, so minus goes right. So I'm going to say this minus 3 goes right 3. And lastly, what is the minus 6 doing? You are minusing 6 on the outside because it's not part of the square root. So you're either going to translate up or down, minus down on the outside. Minus makes it go down. So I'm going to say down 6 right here. And those are all the transformations for number 4. Number 5, given the parent function square root of x, describe the transformation to, and then it says f of x plus 3. So we have a 2, this is multiplying on the outside, and since this 3 is on the inside of parentheses, you are adding on the inside. And so I just need to look at my properties for what happens if I multiply on the outside and what happens if I add on the inside. So I'm going to go and I'm going to look at the multiply on the outside. If it's greater than 1, which 2 is, that's going to be a vertical stretch. And then what if I add a number on the inside? So inside plus goes left. So this tells me the 2 is going to be a vertical stretch by a factor of 2, and the plus 3 is going to go left 3. So there we go. I wrote down what I just said, and that's all there is to it. So this is a function, function notation type of problem, where I'm not even, I gave you the square root function, but you almost don't even need to know that. You just need to know that what happens if you have a 2 on the outside. See, it's on the outside of f of x, so that means it'll be like a 2 right here. And then if I have a plus 3 on the inside, what would happen if there was, it said x plus 3 on the inside of this radical? That's what the question is ultimately asking you. Let's move on to number 6. What's the domain and range of, and you have negative 2 times the square root of x minus 5. Express the answer in interval notation and set notation. So guess what I'm going to do? I'm going to graph this. Okay, so you can see that when I graphed it, it did 2 things mostly. Well, it did 3 things. It reflected over the x-axis, a vertical stretch by a factor of 2, and went right 5. How's that going to affect the domain and range? The fact that it went right 5 will affect the domain, because domain is on the x-axis moving left and right. So, and then the fact that it flipped over the x-axis will affect the range. Because it starts at 5 and it's moving to the right. So it doesn't matter if it's opening up or down. If it's moving to the right, that's moving towards positive infinity for the domain. So the domain started at 5 and then it moved towards positive infinity. Or you can express that as interval notation, so x such that x is greater than or equal to 5, and, or that's set notation, sorry. So that's the domain. What's the range? The range starts at not 5. 5 is on the x-axis. Where is it starting on the y-axis? Starting at 0, and then where's it going? It's going down. So I don't have any clear room to write this. So I'll just write it over here on the side. The range is starting at 0, so 0 to infinity, except it's not going from 0 to infinity, it's going down. So it's going, the range is going from negative infinity to 0, okay? And then, but you can touch the 0, so put that in a bracket still. But yeah, negative infinity is less than 0, so that has to come first. If you were to write this in set builder notation, you say y such that, and then what's happening? It's going down, right? It's starting from 0 and going down, so y is less than or equal to 0. And so that would be the correct range for number 6. All right? So anytime something moves left or right, people get confused. They see the 5 and they want to put it in both things. You need to relate that. The 5 is moving on the x-axis, so you only need to relate that to the domain, okay? If it moves up or down, then you can relate that to the range, but it didn't move up or down. It just moved to the side. Okay, number 7. Describe the effects of the transformation from the cube root of x to 4 times the cube root of x. So what's 4 doing to the cube root of x? Is that adding, subtracting, multiplying, or dividing? It is multiplying, because it just says 4 and then there's nothing else there. So 4 is greater than 1. That's going to tell me there's a vertical stretch. So all I need to say is just that, vertical stretch by a factor of 4. So there I wrote down my answer. Now, if you need to look at the graph, by all means, please do. I'm going to type in the cube root of x, and then I'm going to type in the 4 times the cube root of x. And so let's see if I can get this to fit on here. I'll just paste it real small right there. So you see that it is vertically stretching, as if you were pulling on the blue graph from the top and the bottom and stretching it like a rubber band. So if it's taller, it's vertically stretching. Possibly horizontally compressing, but that's only if it's on the inside. All right, number 8. Given the parent function f of x equals the absolute value of x, describe the transformation to, and then this is a 0.5, so that's a fraction. 0.5 is the same thing as 1 over 2. So you have 0.5 times f of x plus 3 minus 4. So what is the 0.5 doing? You are multiplying that because it's written right outside it. And so it is on the outside, but it's less than 1. So that's a vertical compression. And then we've covered all the other stuff, adding and subtracting on the outside. So this is a vertical compression by a factor of 0.5. What is the plus 3 doing? It's on the inside, so that means it can go left 3 units. What's the minus 4 doing? That's on the outside, so that means it can only go down 4 units. And that is the answer to number 8. Number 9. Describe the transformation for the following equation. You have 1 over x minus 2 minus 3, and the parent function was 1 over x. So this is your rational parent function. If you want to make note of that, by all means, please do. All right, but if you get stuck on this because the rational one confuses people the most, graph it. I'm going to go over the non-graphing side first. So I have an x minus 2. Is that on the inside or the outside? And if it'll help you answer the question, look at the minus 3. That's clearly on the outside. So this minus 2 must be on the inside because it's part of the 1 over the x. So that is going to make it go right 2 units because minus goes right. And so then the minus 3 is just going to make it go down 3 because it's minusing 3 on the outside. So what I recommend doing is graphing the original and then graphing this, since I had 2 things, graphing it in pieces. So I'll show you what I'm talking about. Okay, so admittedly, the graph looks a little crazy, but 1 over x is in green, and then 1 over x minus 2. I said it went right 2. Does it look like it shifted to the right? Yes, it does. How can you tell that it shifted to the right 2? Well, you got to find a point that goes through a corner on the grid. So this point right here goes over 1, 2. And so that's how you know for sure it goes over to the right 2 units. And then how can you tell that it goes down 3 units? Well, looking at this same point, 1, 2, 3, down 3 units. So graph it in pieces like this to help you identify each kind of transformation. It really, really helps. Number 10, what is the parent function if you are given negative 2x minus 4 raised to the third power and then plus 6? List all transformations. Okay, so anytime you see the power of 3, that makes it a cubic function. Remember, anytime you see power of 2, quadratic. Power of 3, cubic function. So what is the negative doing? It's in parentheses, so that is on the inside. So negative on the inside will make it reflect on the y-axis. I have a 2 on the inside, so let's go to the very top of the notes to look at the 2. So here, reflect on the y-axis, negative on the inside. So if you're multiplying a number greater than 1 on the inside of a function, that's a horizontal compression, and flip the number for the factor, okay? So I'm going to go all the way back down here, and I'm going to say a horizontal compression by a factor of, flip the number 1 over 2. And then we have a minus 4, and that's on the inside. So minusing 4 on the inside can mean that, I don't know, I'm trailing off here. Minusing 4 on the inside can only mean that you're going to move left or right. Because if you add or subtract on the inside, it goes left and right, not up or down. So I had a minus 4, so that makes it go right 4 units. So the very last thing, what's that plus 6 doing? It's plussing on the outside, so plus goes up. So you just say it moved up 6 units, and that's all the transformations, and we define the function as well. So that means number 10 is done. And I just gotta fix this. And so if number 10 is done, then we're done with the we do side. Thank you for watching, and good luck and goodbye.